In this section, Box and Whisker Plots, we will be able to compare, contrast, and analyze data, including data from real-world situations displayed in Box and Whisker Plots. Let's take a look at this situation. A study was conducted to determine the number of cars that passed through two intersections each day for 20 days. The results are summarized in these box and whisker plots. Intersection 1, intersection 2, box and whisker plots. Which statement is best supported by these data? So best supported means true. Choice A, the range of the data for intersection 2 is twice the range of the data for intersection 1. The choice B, the lower quartile for intersection 1 is greater than the lower quartile for intersection 2. Choice C, the interquartile range for intersection 1 is the same as the interquartile range for intersection 2. Choice D, the total number of vehicles that passed through intersection 2 is greater than the total number of vehicles that passed through intersection 1. There's a lot of vocabulary here we need to know to answer this question. Let's revisit this question after we study some of the new vocabulary. First of all, what is a box and whisker plot? That's a figure used to map the spread of data or observations compared to the median. That's really important here that it's compared to the median because we use other types of measuring compared to the mean. The box and whisker plot divides the data into equally sized portions where 25% of the data is represented by each quartile. What that means is, even though these boxes look different size, it's because there's more of a spread of data, but there's the same amount of data in each of these sections. In this first section, there's 25% or 1/4 of the data. This second section, 25% of the data. This next section, also 25%, and the last section, 25%. So 25% 4 times makes 100%. Each section is divided equally. The minimum value, or the min, is the smallest value in the data set. That's the minimum, or the min is the smallest. So looking at this picture, the lowest point is at 40. So 40 is the minimum of this data set. The maximum, similarly, or the max, is the largest value in the data set. So we look where the largest point is, and that's at 100. 100 is the max. The median, we've talked about previously, or the mean, which is what it shows in your calculator, is the middle of the data. In this picture, the middle is showed at 70. So 70 is the median. Then we have the lower quartile, or Q1 as it's sometimes abbreviated, and the upper quartile, or Q3. These are the middle of the data, either below the median or the middle of the data above the median. So if the median is right here, the point that's in the middle between the lowest and the median is this point right here. This right here would be the lower quartile. 60 is the lower quartile in this picture. Between the median and the maximum, this point right here is shown at between 80 and 80, 80 and 90, that's 85. 85 is the upper quartile. Then we have the range. Just to review, the difference between the max and the min values. So if we know, again, the min is 40 and the max is 100, then the range would be 100 minus 40, or 60. 60 is the range. Then we have the interquartile range, or abbreviated IQR. That's the difference between the upper quartile and the lower quartile. So in this picture, we have the upper quartile, there's the point at 85, and the lower quartile, there's the point at 60. So this is going to be the difference between those two, 85 minus 60, or 25. Let's answer some questions based on the above box and whisker plots. A, if the above box and whisker plot is based on 240 data points, how many are in each quartile? Well, remember that each quartile is divided up into 4 parts that are all equal, 25%, 25%, 25%, 25%. So if each quartile is 25%, that's a quarter. Remember a quarter, like 1/4. So I take my 240 and I divide it by 4. That makes 60. There are 60 data points in each quartile. How many data points are greater than 60? Now here they're talking about the data point 60. So we're looking at 60 and we're asking how many data points are above this point. Well, if only one section, 25% is below it, that means I've got 3 sections above it. So there are, remember we just said there's 60 data points in each quartile. So that means 60 here, 60 here, 60, and 60. So how many are greater than the data point 60? Here's the data point 60. I've got 1, 2, 3 60s. So 60 plus 60 plus 60, or 60 times 3 to make 180. Situation 2. Data was collected on the weight of birds, plot A, and squirrels, plot B. 278 birds and 125 squirrels were weighed in grams. Compare box and whisker plots A and B to answer each question. A, which plot has the lesser range? So that means we need to calculate the range for each of the plots. The range for plot A. If I look at plot A, the range is the biggest minus the smallest. Well, the biggest is at 100, the maximum. The smallest, or the minimum, is at 50. So that's 100 minus 50. For plot B, the range, the maximum, same place, 100. The minimum, different number, 40. So if we compute those, this one is 50, the other one is 60. Lesser means smaller. And which one is smaller? 50. 50 is less than 60. So which plot has it? The answer is plot A. This is all our work that proves it. Let's try another. Which plot has the greater interquartile range, or IQR for short? Let's look at each plot. Plot A, interquartile range, remember that is the measurement of Q3 upper quartile minus lower quartile. So let's look at plot A. Upper quartile is here. This is Q3, and that happens at 80. Lower quartile, or Q1, happens at 65. Total that for 15. For plot B, Q3 is here. That is at 85. Q1 is here, lower quartile, that is at 60. So that makes 25. We're asked to find the greater interquartile range. Well, 25 is greater than 15, so that would be plot B. Remember always to answer the question that's being asked. Next question. What percent of data in plot B is between 60 and 85? So we're only looking at plot B, and between 60, which is at Q1, and 85, which is at Q3, this is two of the four parts. This is 25% and 25%. So between those, 25% plus 25% makes 50%. D. How many birds are below the lower quartile? So remember, birds is plot A, and there are 278 birds altogether. So if we're looking for the number of birds in a particular section, we have to divide the total amount by the number of sections. And there are four sections, 1, 2, 3, 4, four quartiles. So we're going to, or excuse me, four sections. So we're going to divide that by 4 and we get 69.5. That means we have 69 here and 69 here and 69 here and 69 here. Why the 0.5? Because there is an odd amount and we have a half means that there's a point, a data point that is exactly on that quartile, that lower quartile. So there's 69 here with 1 on that data point, 69 here with 1 on that data point. So there's exactly half above the median and half below the median. How many birds are below the lower quartile? Just those 69. How many total animals, so all together, are less than 70 grams of weight? So 70, notice that that's right in the middle. That's our median. So below 70 is exactly half of the amount of animals. So total amount of animals is 278 birds and 125 squirrels, and then half of that total amount. So altogether, we have 403 animals. Divide that by 2 to get half of that, and we have approximately 201. Now you know this isn't going to make exactly 201. This is going to make 201.5. But remember, the 0.5 is because one of the data points is sitting on the quartile, sitting on the median, 201. Which category of animals, birds or squirrels, that's how we'll answer, has the most animals that weigh less than 70 grams? So each one divided by 2, because less than 70, remember that's half, 278 divided by 2 is 139, and squirrels is 125 divided by 2, that's 62.5. So which category of animals has the most? This is the bigger number, and this was the birds. So birds have the most. These are calculator instructions if you need to create a box and whisker plot. Before we finish, let's go back up to that first situation. Now we can solve this problem because we understand how to calculate range and the quartiles and the interquartile range. The range of intersection 2, well, looking at intersection 2, our max is 650, our min is 250. 650 minus 250 makes 400. The range for intersection 1, so I'm looking at intersection 1, and the range, the max is at 550, the min is at 350. 550 minus 350 makes 200. So they're saying that the range of intersection 2 is twice the range for intersection 1, Well, 400 is twice 200. So this is a true statement because 400 is 200 times 2. That is a correct statement. Let's read the others just to check our work. The lower quartile for intersection 1, so the lower quartile is what we need. The lower quartile is here for intersection 1, and that is between 350 and 400, so that's 375, is greater than the lower quartile for intersection 2. So the lower quartile in intersection 2 is at 400. 375 is greater than 400. That is not true. How about the interquartile range for intersection 1? Interquartile range. So the upper quartile is at 500. So we're going 500 minus the lower quartile, 375, makes 125. And for intersection 2, we've got upper quartile at 550 and lower quartile at 400 to make 150. So is it the same? No, it's not. Not the same. Finally, the total number of vehicles that pass through the intersection is greater than the total number of vehicles for the other intersection. We have no information on total vehicles. So we can't say that that is best supported by this data. Try to summarize why you think a box and whisker plot is useful when analyzing data. See you in class.